So this video is designed to help you understand factoring trinomials in the form of ax squared plus bx plus c. Now a lot of times in this example, for one, when you just have n squared plus 4n minus 12 and there's no coefficient of the first term, then we really could call that just x squared plus bx plus c, because there's a coefficient of 1 there and we don't really need the 1. It's really kind of the same process either way. So before we get started factoring this, just want to do a little thought bubble over here. And what I'm remembering about this is when we first learned about polynomials and binomials and all that, we learned how to multiply binomials. And we had this thing called FOIL. And so we had two parentheses with two terms each, these binomials that we would multiply out and we would get a larger polynomial, like a trinomial. So when we're factoring, we're working backwards. Now we have the trinomial and we're trying to break it into its factors. It's kind of like 4 times 5 is 20, so factors of 20 are 4 and 5. And so when I'm doing this FOIL thing, I know that since my first term is an n squared, I absolutely have to have an n here and an n here. So one technique in factoring is called guess and check, and it's not the preferred method, but it does work sometimes. But we can use that technique to kind of dial in and get closer to our factoring and see if something makes sense. So as I look at the rest of it, this term of my polynomial is a negative number. I can only get a negative number by multiplying a positive and a negative number together. So that tells me in my factoring that one of my binomials has to be a positive and the other one has to be a negative, or one adding and one subtracting, so that when I multiply those last terms, remember it's first, outer, inner, last, those last terms have to give me negative 12. Now I also know that I have my middle term being a 4n. That means there's 4 more positive n's than negative n's when I add those middle terms. That helps me figure out how to factor this thing as I'm thinking about it. So let's go over the technique that we use. The technique is to take this number here, this a term, which in this case is 1, so we don't really need to use it, and multiply it by the c term. So that gives me negative 12, because 1 times negative 12 is negative 12. Now in this case it's a little simpler because of that 1, so all I need to do is find all the factors that make negative 12. So let's make an exhaustive list of those systematically. Negative 1 times a positive 12 would give me negative 12. But likewise, a 1 times a negative 12 will also yield a product of negative 12. Then negative 2 and positive 6, positive 2 and negative 6, negative 3 and positive 4, positive 3 and negative 4. Now all of these will multiply to negative 12. And when I look through my list, once I've found all the possible factors of the a term times the c term, and I want to find ones that add to the middle term. So I look at these ones, the sum would be 11. Negative 1 plus 12 is 11. This one would be negative 11. This would be a positive 4. This would be a negative 4. This would be 1 and negative 1. And when I look at those, I'm looking for the one that adds up to 4. So I'm going to circle this one right here. Negative 2 and positive 6. So now when I split this into two factors, I know that one will be n minus 2 and the other one will be n plus 6. So let's go back over here and verify that. N plus 6 and an n minus 2, negative times, or positive times a negative does indeed give me a negative answer. And of course, as always, we can FOIL this out to verify our results. So if I take n times n, I get n squared. N times 6 gives me 6n. Negative 2 times n gives me a negative 2n, and a negative 2 times a positive 6 gives me a negative 12. Notice how I purposely put these terms together because I'm going to end up combining those like terms. 6n and a negative 2n gives the result of 4n, and that's where we get this middle term. And we get negative 12 here on the end, and n squared. So when I work it out backwards, I FOIL it out, I get to my original polynomial. So I have another example for you, and this one's a little bit different, so I wanted to show you what happens in a special case. Same process as before. You have a 1 in front of this x, the coefficient of x squared, the x squared term is 1. So 1 times 24 gives me 24. And again, I'm going to look for all the factors of 24. Before I do that, I want to remember that my last term is positive. I can only get a positive by having 2 positives multiplied together or 2 negatives. So that's important when I'm looking at my factors. So factors of 24 are 1 and 24, but I can also have a negative 1 and a negative 24. That makes 24. Now, let me hold on here for just a second. When I'm looking at this, I have to have a negative middle term. The only way to get a negative middle term is to have 2 terms that are negative, because when I'm adding negatives, I have to have a lot of negatives to get negative terms. So this is not going to work. 1 and 24 will not give me a negative 4 in any way. So I don't need to use any positive and positive factors here. So that'll save me a little bit of time. So I got negative 1, negative 24. I got negative 2 and negative 12. Negative 3 and negative 8 would also make 24. And negative 4 and negative 6. Now remember, the second step is to add these together. We're trying to find something that would combine to make a negative 4x. So I combine a negative 1 and a negative 24, I get a negative 25. Here I'm going to get a negative 14, here a negative 11, and here a negative 10. So once I found all those sums, you remember the next step is to figure out which one of these would add up to make a negative 4x in the middle term. And unfortunately in my list I don't have a negative 4x. And so this is a case where, as long as you've been systematic in finding all the factors of the product of these 2 terms, then we can say this one is not factorable. That's as simple as it gets, and I can't find any factors of it besides 1 and itself. Oh my God.